Okay, geometry fans, our topic for today is starting chapter 3-1, 3-2, transformations, translations, and reflections. That'll be what we emphasize today. So our goals to explain the meaning of translation, reflection, rotation, and dilation. And then we're going to concentrate on translating and reflecting a point or a figure. Before you start, here's your joke of the day. Why did the jaguar eat the tightrope walker? And the answer is, it was craving a well-balanced meal. Okay, so we're going to start with the idea of what it means to be a transformation. If you think of the movie Transformers, or if you think of what does it mean to transform something, basically it means to change. So a transformation is going to be a change. In terms of geometry, that means we take a point or a shape or a figure and we're going to change it in some way. There are 4 ways that we will talk about change: translation, reflection, rotation, dilation. A translation is just a slide or a glide, what we call a slide or glide. So let's say I'm going to draw a letter here. I'm going to draw the letter E. Okay, and I'm going to draw it like this. Okay, like a block letter there, E. And if I want to slide this letter, that means I'm gonna move it. I can move it up or down, left or right. So let's say I slide this letter, and I'll draw it again here. Now it's the same letter, so I'm drawing the same letter. Now, let's say that I take a point, I'm going to put it here in the top left corner. I'm going to call that A. Now this is where we're starting from. Okay, so this point is what we call a pre-image. Okay, a pre-image. Basically, that's where you start. Now, there's a corresponding point after we have done our slide, our translation. It would be here, also the top left corner. When I name that, I'm going to call that A, and I'm going to put a little mark there. I read that as A prime. What it means is that this point corresponds to this point. It matches to this point. Now, A prime is what we call the image. The image is where we finish or where we end. So you have the pre-image where you start, and then you have the image point is where you end. Think of it this way. If you think of a light, so for example, you can tell from looking at my paper here, there is light in the room. Now you actually don't see the light bulb because that's on the ceiling. The light bulb is the pre-image. That's where the light starts from. What you see, though, is the result. You see the end product. So the pre-image is where you start, the image is where you finish. I could take another point, I could put it here, I'll call that B, and that's the pre-image. The image would be here, that is B prime. Now the way that we're sliding this is something like this. If I kind of trace it out, each point in the pre-image corresponds to a point in the image. Now you'll notice that when you do a translation, it doesn't change the shape of the object. So it's going to be this E is congruent to this E, assuming that I draw it perfectly. Okay, I know there are some things that are off. So a translation is where you take an object, you slide it or glide it. A reflection, the word we'll use for reflection that you're familiar with is a flip. You're going to flip an object. So let's say I take my letter E. Now this time I'm going to reflect it across a line. So here's my line. This is called a line of reflection. Line of reflection. So if I reflect this letter across the line, if I'm on the left side of the line, when I reflect it, it's going to go to the right side. Now, we'll talk about kind of the definitions. We'll talk more about that when we get to the back. But one of the ideas is that if I take a point, Okay, I'll call this A. If I'm going to reflect an object, it needs to be the same distance from the line on the other side. So I'm going to kind of eyeball it here. And then I'll draw my letter E. And again, I know it's not perfect here. I could have drawn that better. But here's A and here's A prime. Here's the pre-image, here's the image. Here's the pre-image, B. Here's the image, B prime. Okay, and with the line of reflection, what I know is that each point, these will be the same distance from this line right here. Okay, so a reflection is where you flip the object. Rotation is where you turn. Okay, so for example, if I take my letter E, and I'm going to take a point, I'm going to rotate this E around the point. So let's say I rotate it, I'm going to do 90 degrees. So here it's facing to the right. If I rotate it 90, then what's going to happen is it's going to be facing down. Okay, like that. So if this is my point A, my pre-image, this would be A prime here. Okay, so it's going to look, the rotation is something like this. Now this kind of rotation, this would be, we went 90 degrees, so we turned it 1/4 of the way, 90 degrees, and we went clockwise, we went around the clock. That's a 90-degree clockwise rotation. Now what you'll notice is that for translation, for reflection, and for rotation, the size and the shape of your letter do not change. Now it may be pointing in a different direction, like in a reflection. This would be pointing in a different direction, but it's still congruent. These are congruent shapes. So what we call these, I'm going to write it on the side here, it is an isometry. It's spelled isometry, but we pronounce isometry. That is a congruent transformation. The figures themselves are congruent. Okay? So a reflection is an isometry. A translation is an isometry. And then a rotation, if you turn an object, it's still an isometry. Now the last one, though, is not. The last one is what we call a dilation. Dilation is where you enlarge or reduce something. You make it bigger or smaller. So if we take our letter E, and let's say I take this letter and now I enlarge it. So now it becomes a big letter E. Or let's say I take this and now I make it really small. Okay. These would be dilations. So if I take, here's my pre-image is at point A, here's A prime, and if I do this again, then this would be a double prime. I'd put 2 marks right there. Okay, so this is a dilation. This is definitely not an isometry because these figures are not congruent. They look the same, but they're not going to be congruent. And so this is going to lead us to a new word. We would say that these are similar, and you're going to have the word proportional in there. But similar is not congruent. That means the same shape, but different sizes. Okay, so these are the 4 types of transformations that we're going to talk about over the next few days. But for today, we're going to focus on translation and reflection. Okay, so let's come down here to part 2 where we talk about translations. Translation is just where you slide your figure. Okay, so you move it left, right, up, down. So number 1, it says translate, parallelogram, GHIJ, 3 units to the left and 2 units up. 3 units left, 2 units up. Now, each of these, G, H, I, J, we're going to take each point, and we are going to slide each point 3 units left and 2 units up. So we're going to go, let's say from point G, we're going to count left 3, up 2. That's going to be the image, and I'm going to call that G prime. If we take H, we're going to translate the same way. Left 3, up 2. And there's H prime. Point I, left 3, up 2. There's I prime. And then J, left 3, up 2. As long as we do the same thing to each point, then now we're going to graph them. So this parallelogram, the image, should be identical. It should be congruent to the pre-image. Okay, and you can look at this and you can measure the sides and you can say, yes, they are going to be the same. Now, the way that we write this, there are a couple ways that we can show this symbolically. The first way is I'm going to say capital T x comma y. Now the T stands for translation. X comma y just represents the points. X comma y is what we call the ordered pair. That's what we're graphing. Now, we're going to take each xy, and it says we're going to go 3 to the left and 2 up. So we're going to change the x value by moving 3 spaces left. Well, when you move left, you are subtracting. It's a negative. So we're going to take the x value, we're going to do x minus 3. And for the y value, how are we changing that? We're moving up 2. Up is positive, so we go plus 2. So this is the translation. Each ordered pair, we're going to do x minus 3, which means left 3. And then y plus 2 in the y direction means we go up positive 2. Okay, so this is kind of a different way of looking at this. This can seem confusing. Now I'm going to show you there's a shorthand way, and this is what it does in your book. They write it a little differently. To write x minus 3 and y plus 2, they use this kind of slanted bracket here, and they write minus 3, comma, 2, and then they close it with another slanted bracket. This is what we call a translation vector. Okay, so this is a different way to write it. This is called a translation vector. A vector is just an object that has distance and direction. So this is telling you two things. This is not a point. It's not negative 3 comma 2. That's why we're not using parentheses. That's why we use the slanted brackets here. What this is telling you is you're going left 3, up 2. So it's an easier way of writing this. So let's take number 2. Describe the translation from triangle ABC to triangle DEF. So ABC is our pre-image. DEF, this is our image. This is where we end, where we finish. So we start here, we finish here. The nice thing about this is that because it's visual, all you have to do is count. So let's take point A, and that will correspond to point D, and what we're going to do is we're going to count. In this case, we're going to go right, and we're going to go down. Okay, so we're going to go right, 1, 2, 3, 4, 5, 6, and we're going to go down, 1, 2, 3, 4, 5, 6. So in words, we're going right 6, down 6. Notice that this is not slope. This is x direction, y direction. Now, if we use the translation symbols, we would say the translation of x comma y, each ordered pair changes. We go right 6, which is positive, so that's x plus 6. Take each x value, add 6. To go down is y minus 6. So that we can write it this way, or if we use the translation vector, we would do the bracket, 6 comma negative 6. That's going to be a faster way of writing it. So this would be the vector, the translation vector. So what that means, right 6 and down 6, going kind of like that direction. From B to E, right 6, down 6. From C to F. These would be the vectors here that I'm drawing with the arrows. And that is the end of part 1.